Okay, so welcome members. We are going to see how do we differentiate trig functions. Of course, don't forget to subscribe to the channel. Start with orange. If you have sine f of x and want to differentiate it, when you differentiate sine you get cos, but you first differentiate the angle, then you multiply by the derivative of that angle. The same, when you differentiate cos, for it you get a negative of the derivative of the angle, then you multiply it here, then sine of that angle. So start straight away, differentiate the following. Here is that our f of x is 1, I mean x. So you see, your f of x is x. Differentiate it because then this derivative, so our f5 of x will be 1. Meaning that now my y dx will be, differentiate sine, get this times it, but you get cos, so 1 times differentiate sine, you get cos of that angle, which is this. The same here, you start when I differentiate this, I get 1, so my y dx will be, but because I'm differentiating cos, we get a negative. When I differentiate the angle, I get 1, because I differentiate x, you get 1. When you multiply it here, when you differentiate cos, you get a sine x. When I come here, so now my f of x, the angle is 2x. So what I do, my f of x is 2x. It's the derivative of it is 2. So now my y dx will be, I get a derivative which is 2. Then when I differentiate sine, I get cos of that same angle, cos 2x. When it comes to this, the same idea is that my f of x is 3x. Its derivative will be 3. So meaning from here, my dy dx will be, but when you differentiate cos, we first get a negative. The derivative of f of x, the angle, when you differentiate this, we have got a 3. When you differentiate cos, we get sine of that same angle. When I come to this still, is that now my f of x is 1 minus 5x. When you differentiate this, the derivative of that, you see, I get 0, this will be negative 5. So, meaning that now, my dy respect to x will be now the derivative, here the derivative which is now negative 5. Then, when I differentiate sine, I get cos of that same angle 1 minus 5x. This negative is coming because when you differentiate this angle, we got a negative, so don't confuse that. Now, when you come to tan, now this one, let me line it, we use the product, the quotient rule. Why? Because you know that tan is the same as sine x over cos x. So we first do this, this is sine x over cos x. So this is our u, this is our v. So now we know that here we use the quotient rule. So from here I start my u is sine x. I need du dx. My du dx is, when you differentiate sine, we get cos x. So that my v is cos x. My dv dx is going to be now negative. When you differentiate cos, we get negative sine x. Now, substituting into the formula says that y dx will be v du dx minus u dv dx, the whole over v squared. So I'm going to put into the formula now. I'm going to be having my v, okay, I'm going to have my v as cos x. Then, when the du dx was also cos x. Then minus my u was sine x. So I have my u was sine x. Then dv dx, my dv dx was negative sine x. The whole over here, now I have b squared, my b squared is cos x, the whole squared. So let's simplify and see. This will give me cos squared x. Negative and negative will give me positive sine squared x, the whole over cos squared x, which would be, I know that we have cos squared plus sin squared, that is 1, the whole over cos squared x. And we know the reciprocal of cos squared x, that will be, so now my d dx, my y was tan x. So in the differentiate tan x, we get 1 over cos squared is sec squared x. The same idea, now we will handle this. Now this would be, what is the same as cos x over sin x. You will get its derivative, and it's going to be negative cosec squared. When I come to this, I use the same idea. I'm going to put this one, we will handle this one in your free time. So you know that cosec is also 1 over cos. So from here, my y, start my y is 1 over cos x. This one becomes your u, this one becomes your v. So you start from here, your u is 1, meaning that your du dx is 0. And then your v is cos x. Your dv dx is going to be, this will get negative sin x. So after doing that, then we put in our formula this. So from there, my dy dx is going to be v, which is cos x, into du dx, du dx is 0, then minus u, which is 1, into dv dx, which is negative sin x, the whole over b squared. Our b squared is cos squared x. And this will give us 0, then sin x over cos squared x. And now, you see, I can put this as sin x over cos x times cos x. When I expand this, is that sine? So now from here, 90 dx of my y was sec x is going to be sine over cos, that is tan x. Then you start, this will be 1 over cos, which is going to be sec x, cos this will be minus 1 over cos x. And that's how we differentiate that. So meaning you can handle now sec. So to summarize for you the table is going to be summarized like this. Here I'm going to put the function. Then inside I will put the derivative. So we said if the function is sin x, its derivative is cos x. From there, then if we have cos x, its function, then the derivative is negative sin. If we have tan x, the derivative is sec squared x. If we have cot x, we will work out this. The answer I'm expecting is negative cosec squared x. If we have sec x, we have seen we get sec x tan x. Here, tan x sec x. If we have now sec x, the answer I'm expecting is negative cosec x, then cot x, that's the answer I'm expecting. So, in that beautiful table members, try to get those ones. I wish you the best. That's how we handle those numbers. Don't forget to subscribe to the channel.